In this lesson video for day 6.2, we're going to be talking about circumference, area, arc length, and area of a sector. Now we're going to go through this first part fairly quickly because this should be a review of previous knowledge. Circumference and area just deal with two specific formulas. Circumference is the complete length around a circle once. If I were to cut a circle at a point and unroll that to a straight segment, that'd be the length of the segment, the circumference. The area is the entire two-dimensional area covered by the border of the actual circle and every part in between. And so we have two formulas for circumference and one for area. Our circumference formula, the first one is this: circumference equals pi times diameter, d for diameter. And our other formula is circumference equals 2 pi times the radius. Okay, radius we talked about in the last class, the length of that radius. And because the radius times 2 equals diameter, that's why I have these two different formulas. Now remember, pi is approximately 3.14, but we have an exact pi value in the calculator we're going to use. And that brings us to area. We have one area formula, and that is that the area is equal to pi r squared. And so we're going to use both of these formulas to solve some problems. Now, we always want to start these kind of problems with the specific formula we're using. So we're going to give a measurement here of either the diameter or the radius, or maybe I'll give you circumference or area, and we should be able to solve these equations for the missing variable. So in this first example, we're given that r is 13, and we are told to find the area. So I'm going to use my area formula. I'm going to start with that. Area equals pi r squared. And I'm going to plug in that 13 for r. So area equals pi times 13 squared. And now we just simply calculate that. Do 13 squared times pi with our calculator. Okay, we do 13 squared times pi. Okay, I could even enter it exactly like it's written here. To get my pi button to show up, to get my pi value, I hit second, and then this exponent key brings that up. Then parentheses, 13, close parentheses, square that, and it looks exactly like what I have written. It gives me the same answer. So our area for this first example is about 530.9. Approximately equal to, because I rounded. And that is in square feet. Okay? And now we're going to take a look at a problem where I am looking for the circumference. So they give me the diameter. Since I'm using diameter, I want to use this circumference formula. So I start with that. C equals pi times diameter. And then I simply plug in 20 for d. So the circumference is equal to pi times 20. So all I have to do is enter that in the calculator, 20 times pi. Again, to get pi to show up, I don't want to just write 3.14. I actually want to use my pi button. So hit second, and then this exponent key right above it brings up pi. And we get 62.8. Our circumference here is approximately 62.8 square inches. Not square inches, I'm sorry, just inches, because it's circumference and that's just a linear measurement. So we can work through our formulas that way, or we can start with a given measurement and work backwards to find something that's missing, like we'll do in this example. All right? So we're going to start with our formula for area still. I'm still using an area measurement. So area equals pi r squared. But now we're going to plug in this number for a. And we're going to solve for r. So we have to work backwards to get r by itself. I want to eventually get r equals my answer. So in order to do that, we have to undo times pi and undo the exponent. That's the first part we will undo, is the times pi. So we divide both sides by pi. And we can do that in the calculator. Okay, on this side it just cancels, but we're going to do 132 divided by pi. And we get 42.0169. I'm going to write several decimals out because I don't want to round too short because it's not my final answer. Okay, so we get that 132 divided by pi is 42 42.0169, and that equals r squared. If I'm working through this equation, r squared is by itself on the right, and this side is now 42.0169. Now you might remember back to our Pythagorean theorem problems that to get r by itself now, I take the square root of both sides. So if I do the square root, I do second and then the x squared button to get square root, 42.0169, close that off, I get about 6.5 when I round that. So the radius of this circle with an area of 132 would be 6.5 centimeters. Okay, so we're going to do some more of these in class together, so don't cross them off. We'll get to those in class because they take a little bit more time to really work through those equations. But I do want us to get to the next portion of the notes, the next big idea. And that is the idea of arc length and sector area. All right, so I want you to write some things down for arc length and sector area. When I talk about a length of an arc, that's different than the measure of an arc. Okay, arc measure is measured in degrees. Some number in degrees. Okay, arc measures are given in degrees, but an arc length, that is a portion of the circle or a portion of the circle's circumference. Because we're dealing with the length all the way around as the circumference, so any portion of that for an arc would just be a portion of the circle's circumference. And we are going to set up formulas for both of these that use proportions. Okay, you remember back to several of our other units, we've talked about proportions, and that is dealing with two equal ratios, two equal fractions. So we're going to set up two fractions. All right, so this first fraction is going to help me understand what part of the circle I'm using a measurement that I know how to find already. So a full circle's measure in degrees would be 360. So we're going to put that on the bottom. The arc portion of that is always an x amount, okay? So some degrees out of a full 360 represents the amount of the circle we're using, or the portion of the circle we're using. That has to be the same as the ratio of the arc length to the total circumference. So on the top of this other fraction, we put capital L, and on the bottom we put our circumference formula, or the letter C. I'm going to write the formula itself, though. Pi times diameter, okay? Okay, this bottom portion is just circumference. I'm going to abbreviate. This capital L stands for arc length. This part X is the arc measure in degrees. Okay? And so that's our proportion, or our formula for calculating arc length. So we're going to practice a problem that uses that, and then we're going to come back and talk about sector area. So we're going to do this next example. We're only going to do part of it because the other part talks about sector area. So we've got some circle X with a radius of 14. I'm going to go ahead and draw that. Okay, circle X, where the radius is 14. Okay. And we've got this intercepted arc, or this arc made by a central angle at X called AB. So there's A, there's B. They're telling you that that central angle, which is the same as the arc measure, is 132 degrees. So that's our X value. X equals 132. They want to know what the length, or the problem here is asking, what is the length of that arc AB? So we're going to use this proportion. All right, so we're going to set up a ratio. We're going to use x over 360. Well, the arc measure in degrees is 132 out of our full 360. That should equal my arc length, which is what I'm solving for, out of pi times diameter. Pi times the diameter of this circle would be twice the radius. So if r is 14, the diameter is 28. Well, since I have a proportion now, there's only one variable left, because pi is a value in the calculator I can use. So the only variable I have is L, so I can cross multiply. When I cross multiply, I'm going to put these two on the left. I have 360 times L has to equal the same as 132 times pi times 28. And notice I haven't actually simplified anything with a calculator yet. I'm going to put all of this in the calculator at once I have L by itself. So whatever that number would equal, my last step would be to divide by 360. So I'm going to go ahead and write that on paper. So the arc length then is whatever that gives me, and that's what I'm going to enter in the calculator. Okay, I'm going to start with all of the top part, 132 parentheses pi, second pi, times 28, close your parentheses, all of that divided by 360. Hit enter, and we get that this arc length is about 32.3 inches, because we're measuring length in inches. Okay? So that's how we calculate arc length. Now I want to go up here before we finish the problem and talk to you about what sector area is. Okay, so arc length is a portion of the circle's circumference. Sector area is a portion of a circle's area. Okay, so it's a portion of a circle's area. I'm still going to set up a proportion then. This left side is still the same, x over 360. That tells you how much of the circle we're using based on arc measure. Okay. This x value is arc measure in degrees out of a full 360. But instead of L for sector area, we're going to use S for instead of L for arc length, we're going to use S for sector area out of our area formula, pi r squared. The formula for the area of a circle is pi r squared. So if I compare part of it to the whole thing, it equals this part to the whole thing. And so then we can cross multiply and solve those, where again, S is your sector area, and pi r squared is your full area. So to finish this problem up, we're going to go back and we're going to solve for our area of our sector. Okay, so the sector, and I should have explained this before, it's a portion of the circle's area, so that's formed, okay, you still have your arc, but then these sides that are formed by that central angle, that shaded region, if I were to fill that all in, represents a sector of a circle. So what we're going to do is we're going to find the area of that sector. We're still going to set up our proportion. We're still using our central angle measure of 132 out of the full 360, and that is equal to the sector area S over pi r squared, but the radius is 14, so it's pi times 14 squared. So we can cross multiply here to solve for S. What that gives me is 360S equals, 360 times S equals 132 times pi times 14 squared. Then we would divide both sides by 360. And so S is equal to this calculation. So we're going to start off with the top of that fraction, 132 parentheses pi times 14 squared, parentheses, divided by 360. And we get that our surface area, or sorry, not surface area, sector area is about 225.8 square inches. It's area, so it's in a square unit measurement. And that's how we find sector area and arc length. And we'll do a little bit more examples in class. But I do want us to talk about kind of where this is going to go from here. So what we're going to do, starting here, is we're going to break down what we call inscribed polygons, like we looked at in the last unit. But these kind of problems are going to use these proportions, okay? These are our formulas for sector area and arc length. And so we need to be able to use those to set up problems for this. So the rest of the notes will get covered in class, but this gives you a starting point over circumference and area, and sector area and arc length.